back to this tutorial series on pandas. In this video, we will take a look at sorting, grouping and aggregating, data analysis, and plotting. Let's get started with sorting a data frame. And this is the data we're working with. We can sort this data frame object using the function sort values and some of its keywords. Here I've used the keywords by and ascending, which do exactly what you think they would. So we are left with a data frame that is sorted by marks in descending order. Note that this operation is also not in place. It does not override the original data frame. Instead of only sorting one column, we can also sort more than one. And if needed, we can specify also a list of orders in which to sort them. Of course, we might also want to sort the data frame by its index column. And for that, we will use the sort index function. And as you can see, it's sorted descending order by the index column. With these functions, you can again specify a different axis if needed. And this might look something like that. Yeah. So we can see that subject and marks have switched positions. Now onto our next topic, grouping and aggregating. You can group a data frame using the group by function, and we will group our data by the subject column. So let's take a look at it. And as you can see, if we try to look at the object we've created, only the type of it is shown. And we have encountered a new object, the data frame group by object. Along with its clunky name, it has some decent features. We can use pretty much the same head and tail functions we know from the data frame and series objects, but as you can see, the output differs. And instead of 2 rows, our output has now 4. That is because a group by object will always evaluate the function for each group separately. And in this case, we have 2 groups. We can make sure by checking the groups attribute of our object. And this results in a dictionary with the groups as labels and the indices of the group members as values. Otherwise, a group by objects works almost the same as a normal data frame object. You might index the object by a column label and calculate the mean of the column, for example. And this also returns the mean of the marks for both subjects. We can also use another function to have a quick look at it. At our object, the size function. This is used to get a quick overview of what kind of data you're working with. Another useful function is the aggregate function, abbreviated AG, which takes a list of functions as an argument and evaluates them each column separately. In this case, as you can see, we've used built-in pandas functions that are specified as strings, and those are evaluated on each different subject. But we could also create our own function. So I've written a getMeanGrade function. It just returns a mean grade for the different subjects, and we can just use this without the quotes around it. And yeah, in this case, we can see that one subject on average performs better than the other. Great. Our next section focuses on data analysis. And first of all, we will discuss normalizing data. I will not explain the mathematical background of these methods. If you don't know, for example, what the standard deviation of some data is, I highly recommend freshening up your memory before you have to use any of these approaches. Some basic knowledge of the underlying method is strongly advised. Now, in order to have some data in which we can actually see the effects of normalizing, I've created a new data frame with only numerical data. And as you can see, each column's values differ greatly from the other columns, which makes them difficult to compare. This is where normalization comes in. It helps us, for example, to quantify changes in the values and just overall makes analyzing the data much easier. There are a lot of different methods of normalization, so I will focus on the two main ones to keep the section relatively as long as the others. The first method is called min-max scaling, which is usually used if two conditions are met. First, the data has no huge outliers, and secondly, the data is approximately uniformly distributed. A good example of this would be age. Most values fall between 0 and 90, and there are lots of people with the same age if your data set is large enough. Anyway, the formula for this method is pretty simple. We take each value subtracted by the minimum value and divide that result by the difference between the minimum and the maximum. And the result will be data scaled to a range between -1 and 1. Secondly, we have the standard scaling or z-score normalization method. This is useful if the data you're working with has few outliers, but no extreme ones, and will result in data with a mean of 0 and a standard deviation of 1. The formula consists of subtracting the data by its mean and dividing that by the data's standard deviation. Next up are functions for correlation and covariance. The correlation function, cor, results in a range from -1 to 1, with 1 meaning a perfect positive correlation between the values. We can also specify which method or correlation coefficient to use this function by supplying one to the method keyword. If you want to find out what other kind of methods there are, I suggest checking out the Pandas documentation. We can also calculate the pairwise covariance of each column by using the cov function. The output you can see is the covariance matrix of the columns of the data frame. That's it for this section. The next one is a little bit easier to follow. It's plotting. We are going to use the marks data frame. This one from before for the first few plots. Pandas has some built-in plotting functions which use matplotlib under the hood. And the one we will focus on is the plot function. Paste that in here. If given no additional keywords, it will draw a simple line graph that represents the numerical data of our data frame. In this function, we can specify a number of keywords First and foremost, the kind keyword, and this code will produce a bar plot with the same data. In addition to changing the kind of the plot, we might also want to change the X and Y axes for better visibility. And I've decided to change the rotation of the names too for the better visibility. Yeah. Let's have a look at some other plots. For an exhaustive list, I will again reference the Pandas documentation. The KDE, or kernel density plot, will show the density function of the data's distribution, or in more broad terms, in this case, the relative amount of each mark. There's also the scatter plot, which will highlight each value at its own point on the grid. And yeah, to look at more beautiful plots, we'll use this random data we have imported at the beginning of the second video. And as we have more than one numerical column this time, the resulting line graph contains more information. And we can also take a look at the box plot of this data, which visualizes some statistical information of each column. All right, that's about it for this video. The next part of this series will be about advanced functions of pandas, such as merging, reshaping, and plotting with seaborn. See you then.